Hello, everyone. Welcome back to our mini lecture. In the first lesson, we learned that the development of an MCU requires writing programs. These programs can be written in machine language, assembly language, or high-level languages like C. Many hardware developments use C language programming, and C51 is a variant of C specifically designed for programming the Intel MCUs 51. It has many advantages over assembly language. In this lesson, we will learn about basic data types in C51, understand the operators in C51, and cover some fundamental statements. In future lessons, we will delve deeper into the use of basic statements through examples. When programming an MCU, it's important to consider that MCUs perform calculations and manipulate data. In MCU operations, the size of the data in variables is limited. We cannot assign arbitrary values to a variable. Variables need to occupy space in the MCU's memory, which can range from a few dozen bytes to several hundred KB. To make efficient use of the MCU's memory space, appropriate data types must be set, as different data types represent different sizes of decimal data. Therefore, before defining a variable, you must declare its type to the compiler, so it can allocate the appropriate space in the MCU's memory. In C51, additional data types are extended based on the standard C language. The basic data types are listed in the table below. Let's explore how to define a variable. The format is as follows. First, the type specifier, followed by the variable name, and the quantity in the square brackets is optional. In the example, the definition indicates that variable I is an unsigned char type with an initial value of uppercase A. It's also possible to define the variable I without assigning an initial value and then assign a value to I later when needed. For other types, be sure that the initial value falls within the range of the defined type. In addition to the types inherited from C language, there are 4 extended types. First, there is the bit type, where a variable of type bit can only have values of 1 or 0, as shown in the example. Second, the SPIT type is used for defining bits in special function registers. It is frequently used for accessing bit-addressable special function registers. For example, the statement in the example accesses pin 2 of port P1 and names it LED. The image displays the use of some SPIT definitions in the reg51.h header file. Third, there is the SFR type. It is defined as an 8-bit special function register type. Our AM contains some special function registers, and we use user-defined identifiers to mark the addresses of these registers. For example, consider this case. The image shows some uses of SFR in the reg51.h header file. Similar to SFR, the SFR16 type occupies 16 bits, and its usage is generally consistent with SFR. C language includes many operators, such as arithmetic operators, relational operators, and logical operators like AND, OR, NOT. Bitwise operators include bitwise AND, bitwise OR, bitwise NOT, bitwise XOR, left shift, and right shift. Bitwise operators are used frequently and have flexible applications. It is important to spend time learning them, as we will expand on them in future program studies. Next, let's explore the basic statements in C51 language. From the perspective of program flow, a program can be divided into 3 basic structures: sequential structure, branch structure, and loop structure. The sequential structure is the simplest and most commonly used. It involves writing statements in the order they need to be executed. Execution proceeds from top to bottom. The branch structure, also known as the selection structure, involves making decisions based on given conditions and then determining which operations to execute or not execute based on the results. The execution process of a selection structure is illustrated as shown in the figure. Common statements include if statements and switch or case statements. The loop structure involves repeatedly executing a specified segment of code under certain control conditions. It is also known as the repetition structure. The following diagram illustrates the execution process of a loop structure. Common statements used in loops include while statements, for statements, and do-while statements. Let's summarize this lesson. We covered the basic data types in C51 language and learned how to define a variable. In addition to the data types inherited from standard C, we explored 4 extended data types in C51. We also reviewed the operators in C51 and the 3 basic program structures: sequential structure, branch structure, and loop structure, along with some fundamental statements associated with them. Finally, here are a few exercises to reinforce the concepts covered today and deepen your understanding. Please complete them carefully. This lesson ends here. See you in the next lecture.